The morning of March 6, 1945, near Cologne, Germany, Oberleutnant Klaus Weber stood beside the captured American tank, notebook in hand, watching as his crew circled the massive vehicle with a mixture of professional curiosity and undisguised dread. The tank bore the designation T-26E3, painted in American olive drab, with a white star still visible on the turret. Serial number 26. This particular machine had been knocked out during street fighting in Cologne's urban maze just days earlier, its crew abandoning it after a Panzerfaust strike had damaged the track and immobilized the vehicle. Weber commanded the Technical Evaluation Section of Panzer Brigade 106, responsible for assessing captured enemy equipment and reporting findings to Army High Command. In the chaos of Germany's collapsing Western Front, such duties had become increasingly important as Wehrmacht intelligence struggled to understand the capabilities of new American weapons appearing with alarming frequency. This tank, which American crews were calling the Pershing, represented something entirely unexpected. Intelligence reports had warned of a new heavy tank entering service, but seeing the physical vehicle made those warnings terrifyingly real. The Pershing measured over 6 meters in length, not counting its impressively long gun barrel. It weighed 42 tons, according to markings found in the crew compartment. Most concerning was the main armament, a 90mm gun that dwarfed the 75mm weapons mounted on most German tanks. Weber's orders were explicit: measure the armor thickness, evaluate the automotive components, assess the vehicle's combat capabilities, determine what this new American tank meant for German forces, desperately defending the Reich's shrinking borders. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The crew began their inspection methodically, photographing the vehicle from multiple angles, measuring track width, recording suspension details. They documented everything with German thoroughness, knowing that their findings would circulate through Wehrmacht technical branches within days. The Pershing represented America's answer to German heavy tanks, a response to reports that Sherman struggled against Panthers and Tigers. Now that response sat before them, captured but largely intact, ready to reveal its secrets. Spring 1945 found Germany's armoured forces in desperate circumstances. Allied armies were closing from both east and west. Fuel shortages limited tank operations to brief defensive engagements. Spare parts had become nearly impossible to obtain, as factories fell to advancing enemies or were destroyed by strategic bombing. In this context, understanding enemy capabilities had become critical for commanders trying to husband their dwindling resources effectively. Weber had joined the Wehrmacht in 1939 as a young engineer officer, trained in automotive mechanics at the technical school in Munich. He had served in France, Russia, and Italy, evaluating captured Soviet T-34 seconds, British Churchills, and numerous Sherman variants. He understood Allied tank development better than most German officers, having tracked the evolution of enemy armour through 4 years of examination and testing. This experience made his current assignment both fascinating and terrifying. The Pershing represented a new category of American tank, one that suggested the Americans had finally learned lessons the Germans thought they had exclusive understanding of. The initial measurements confirmed what visual inspection had suggested. The frontal armour measured 100 mm thick on the hull, sloped at 46 degrees from vertical. The turret front measured 114 mm. These were not Sherman-level protections. These were figures approaching German heavy tank standards. Weber recorded the measurements carefully, comparing them mentally to known German vehicles. The Panther's frontal hull armour was 80 mm at 55 degrees. The Tiger's frontal armour was 100 mm vertical. The Pershing split the difference, providing protection comparable to Germany's best tanks, but in a vehicle that weighed significantly less than a Tiger. The suspension caught immediate attention. American tanks typically used vertical volute spring suspension, a simple, reliable system that made for rough rides but required minimal maintenance. The Pershing employed torsion bar suspension similar to German designs, with independent road wheels that promised better cross-country performance. This represented a significant departure from standard American practice, suggesting that American engineers had studied German suspension systems and incorporated those principles into their new design. Weber's crew examined the tracks, noting they were significantly wider than Sherman tracks at 24 inches. This distributed the tank's weight more effectively, reducing ground pressure and improving mobility on soft terrain. The drive sprocket was larger and more robust than Sherman components, clearly designed to handle increased torque from a more powerful engine. Every detail suggested careful engineering aimed at creating a vehicle that could match German capabilities. The automotive examination revealed the most significant departures from previous American practice. The engine was a Ford GAF V12 gasoline engine, producing 500 horsepower, substantially more powerful than the Continental Radial or Ford GAA V8 engines used in Shermans. The transmission was an entirely new design, a General Motors hydromatic automatic transmission adapted for armored vehicle use. Weber recognized this immediately as revolutionary. German tanks universally employed manual transmissions, requiring skilled, double clutching and careful rev matching. The Pershing's automatic transmission would make the tank dramatically easier to drive, requiring minimal specialized training. The crew spent hours examining the transmission, photographing its components, measuring gear ratios. The automatic design eliminated clutch pedal and complex shifting patterns. The driver simply selected a range, forward or reverse, and the transmission handled all gear changes automatically based on engine speed and load. This meant that ordinary soldiers with basic automotive knowledge could operate the Pershing effectively, while German heavy tanks required months of specialized driver training to avoid transmission damage through improper operation. March 7, 1945. Panzer Testing Facility, Sennelager, Germany. The captured Pershing arrived by rail transport, carefully loaded onto a heavy flat car for the journey from Cologne. Wehrmacht engineers at Sennelager had prepared comprehensive testing protocols, eager to evaluate America's new heavy tank under controlled conditions. The facility, located in North Rhine-Westphalia, served as a primary testing ground for German armored vehicles and captured enemy equipment. The Pershing rolled off the rail car under its own power, its damaged track having been repaired by German mechanics using fabricated replacement links. The engine started easily, surprising German technicians accustomed to temperamental German tank engines that required careful warm-up procedures and frequent adjustment. The Ford GAF V12 simply roared to life with minimal preparation, idled smoothly, and responded immediately to throttle inputs without hesitation or stumbling. Test engineers established priorities for evaluation. First, measure the armor protection through direct fire testing using German anti-tank weapons. Second, evaluate automotive performance and reliability. Third, assess the gun's capabilities and fire control systems. Fourth, examine the tank's overall design philosophy and manufacturing quality. The testing would take weeks under normal circumstances, but Germany's deteriorating military situation meant results were needed immediately. The armor testing began with smaller caliber weapons and progressed to heavier guns. Engineers positioned armor plates cut from damaged German tanks at various distances, simulating combat engagement ranges. They fired Panzerfaust anti-tank rockets, noting that hits on the frontal armor failed to penetrate except at point-blank range. The sloped 100mm frontal plate deflected rockets that would have destroyed lighter American tanks easily. Testing progressed to the 75mm PaK-40 anti-tank gun, standard equipment for German infantry units. Engineers loaded armor-piercing rounds and engaged the Pershing's frontal armor from 1,000 meters. The rounds struck with characteristic sharp cracks, leaving deep gouges in the armor plate but failing to penetrate. At 500 meters, the PaK-40 achieved marginal penetration, punching through only when striking perfectly perpendicular to the sloped armor. Even then, the penetration was barely sufficient to defeat the protection. The critical test involved the 75mm KWK-42 gun mounted on Panther tanks, Germany's most numerous heavy tank, and the backbone of Wehrmacht armored forces in early 1945. Engineers positioned a Panther at various ranges, and fired standard armor-piercing rounds at the captured Pershing's frontal armor. The results were devastating for German confidence. At 2,000 meters, the Panther's gun could not penetrate the Pershing's frontal armor. The rounds struck hard, creating impressive impacts, but the sloped 100mm plate defeated them consistently. At 1,500 meters, penetration remained impossible. The armor's combination of thickness and slope angle provided protection that exceeded the Panther gun's penetration capability at typical combat engagement ranges. Only at ranges below 800 meters did the Panther's gun achieve reliable penetration of the Pershing's frontal hull armor, and even then, shots had to strike near perpendicular to the slope. Glancing hits at angles deflected harmlessly. The turret front, with its 114mm of armor, proved even more resistant. The Panther's gun could not reliably penetrate the Pershing's turret frontally at any practical combat range. Weber watched these tests with growing alarm. The Panther represented Germany's answer to the Soviet T-34, incorporating sloped armor and a powerful high-velocity gun. It had been designed specifically to outmatch any Allied tank then in service. Now American engineers had created a vehicle that the Panther could not defeat frontally except at dangerously close range. The implications were clear and terrifying. German tank crews facing Pershings would need to maneuver for flank shots, exposing themselves to the American tank's powerful 90mm gun, while their own weapons proved ineffective. The testing revealed another crucial detail. The Pershing's side armor, measuring 76mm, was substantially thicker than Sherman side armor, but still vulnerable to German anti-tank weapons. This suggested that American engineers understood the importance of frontal protection in tank versus tank engagements, but accepted that side armor would always be vulnerable to create a vehicle of reasonable weight. This represented sound tactical thinking, prioritizing protection against the most common threat directions. The 90mm gun mounted on the Pershing received intensive examination. Engineers measured the barrel length at 52 calibers, giving a total length of over 4.5 meters. The gun used two-piece ammunition with separate projectile and propellant charge, similar to German tank guns. The mounting was electrically powered with both hydraulic and manual traverse options, providing reliable turret control even if main power failed. German engineers test-fired captured 90mm ammunition against armor plates, simulating German tank protection. The results confirmed their worst fears. The 90mm armor-piercing round could penetrate 150mm of vertical armor at 1,000 meters range. This meant the Pershing's gun could defeat the frontal armor of any German tank in service, including the Tiger II, from ranges where German guns could not respond effectively. The fire control system impressed German observers particularly. The Pershing employed a coincidence rangefinder integrated with the gun sight, allowing gunners to accurately determine range to target before firing. This reduced ammunition waste and increased first shot hit probability significantly. German tanks used similar systems, but the American implementation appeared more refined and easier to use, with clearer optics and smoother adjustment controls. Testing progressed to automotive performance evaluation. Engineers drove the Pershing through obstacle courses designed to stress drivetrain components and suspension systems. They measured fuel consumption, recorded engine temperatures, documented transmission behavior under varying loads. The results contradicted German expectations about American automotive engineering. The automatic transmission performed flawlessly throughout testing. Gear changes were smooth and instantaneous, without driver intervention. The tank could negotiate obstacles that would require careful clutch work and precise shifting in German vehicles, accomplishing these maneuvers automatically without risk of operator error damaging the drivetrain. German test drivers, accustomed to manual transmissions requiring constant attention and skill, found the Pershing remarkably easy to operate. The torsion bar suspension provided excellent cross-country mobility. The Pershing traversed rough terrain at speeds comparable to much lighter vehicles, the independent suspension allowing each road wheel to follow ground contours without transmitting excessive shock to the hull. German engineers noted that crew fatigue would be significantly reduced compared to tanks with harsher suspension systems, allowing longer operational periods without exhausting tank crews. Engine reliability exceeded expectations based on previous American tank evaluations. The Ford GAF 512 ran smoothly throughout extended testing, maintaining consistent power output without overheating or losing performance. The cooling system proved adequate for sustained operations, the engine temperature remaining within acceptable limits, even during maximum power climbs and extended high-speed runs. German observers contrasted this with their own experience, where Panther and Tiger engines required careful monitoring and frequent cooling stops during intensive operations. By mid-March 1945, Sennelager had accumulated sufficient data to produce preliminary technical reports. These documents, classified secret and intended for senior Wehrmacht officers, painted a sobering picture of American tank development. The Pershing represented a fundamental shift in American armored vehicle philosophy, incorporating lessons learned from years of combat against German tanks while maintaining the automotive reliability that characterized American manufacturing. Internal Wehrmacht assessments documented observations that confirmed Germany's worst fears about losing the technological arms race. American engineers had studied German tank design, identified key advantages like sloped armor and torsion bar suspension, and incorporated those features into a vehicle that retained superior American automotive engineering. The result was a tank that combined the protection and firepower of German heavy tanks with the reliability and ease of operation of American medium tanks. The comparison with German tank reliability became impossible to ignore as testing continued. The Pershing required minimal maintenance between test runs. Simple daily checks of fluid levels and track tension sufficed to keep the vehicle operational. By contrast, German tanks demanded extensive daily maintenance, with Panthers requiring hours of work to maintain transmission health and Tigers needing constant attention to complex systems. The automatic transmission eliminated the most common source of German tank failures. Panther transmissions broke regularly because drivers, under combat stress, shifted incorrectly or overloaded gears. The Pershing's transmission simply could not be damaged by driver error, as all shifting occurred automatically, based on mechanical and hydraulic principles. This single design feature represented an enormous reliability advantage that German engineers had never considered implementing. Additional testing revealed the Pershing's generous design margins. The drivetrain components originally specified for the 42-ton vehicle showed no signs of stress or excessive wear, even after intensive testing. Engineers calculated that the same components could easily handle a heavier vehicle or more powerful engine without requiring reinforcement. This suggested American designers had built substantial safety factors into their specifications, ensuring components would survive combat stresses that might exceed normal operational parameters. German engineers tended to calculate such margins as waste, excess capacity that consumed scarce materials without immediate benefit. American engineers clearly viewed margins as insurance, guaranteeing reliability under the worst possible conditions. In the context of 1945, with German tanks breaking down from worn components and inadequate materials, this philosophical difference had become critically important. April 1945 brought expanded testing as Wehrmacht forces retreated across Germany, and additional intelligence about Pershing deployments reached high command. The 3rd Armoured Division had received 20 Pershings in February 1945, deploying them to combat units for operational evaluation. These tanks had seen action at Remagen, where one Pershing famously destroyed a Panther in a close-range duel near Cologne Cathedral, the engagement captured on film by an army cameraman. Reports from the Eastern Front indicated that no Pershings had appeared in combat against Soviet forces, with all available vehicles allocated to the Western Front against Germany. This suggested limited production numbers, with America prioritizing the European theater for deployment. Intelligence estimates suggested fewer than 200 Pershings had been built by early 1945, indicating the design remained in limited production. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The limited deployment numbers provided small comfort to German tank commanders who understood the broader implications. America had developed a heavy tank comparable to German designs, while maintaining production of tens of thousands of Shermans. This demonstrated industrial capacity to pursue multiple tank programs simultaneously, a capability Germany had never possessed, even before strategic bombing devastated manufacturing capacity. Weber compiled his findings into a comprehensive technical report submitted to Army High Command in mid-April 1945. The document detailed every aspect of Pershing capabilities, providing German commanders with accurate information about the newest American threat. The conclusions were unambiguous and deeply pessimistic about German prospects. The Pershing's frontal armor could not be defeated by standard German anti-tank weapons at typical combat ranges. The Panther's 75mm gun, backbone of German armored forces, proved inadequate against this new American tank. German forces would need to employ 88mm guns, Panzerfaust rockets at close range, or flanking maneuvers to defeat Pershings. None of these options were reliably available in Germany's deteriorating tactical situation. The report noted that Pershing crews enjoyed significant advantages over German tankers. The automatic transmission reduced driver workload dramatically, allowing crews to focus on combat effectiveness rather than mechanical operation. The powerful 90mm gun could engage German tanks from ranges where return fire was ineffective. The combination of heavy armor and excellent automotive reliability meant Pershings could sustain operations that would leave German tanks broken down or destroyed. Weber's assessment included comparison data from previous American tank evaluations. The Pershing represented as significant an advance over the Sherman as the Sherman had been over earlier American tanks. Where Shermans had been vulnerable to German anti-tank weapons, Pershings were resistant. Where Shermans had relied on numerical superiority and tactical mobility, Pershings could engage German tanks on equal or superior terms in direct gunnery duels. The manufacturing quality impressed German observers as much as the tactical capabilities. American tanks were built with consistent quality, regardless of which factory produced them. Components from different manufacturers were fully interchangeable without adjustment. This standardization, routine in American automotive industry, remained largely theoretical in German tank production, where each manufacturer introduced subtle variations preventing true parts interchangeability. Field reports from German units encountering Pershings in combat reinforced Sennelager testing data with real-world operational experience. Wehrmacht tank commanders reported that engaging Pershings frontally was suicidal unless firing from ambush positions with first-shot advantages. The American tanks absorbed hits that would have destroyed Shermans, returning fire with devastating effect. The engagement near Cologne Cathedral on March 6, 1945, provided the most detailed combat assessment. A Panther from the 506th Heavy Panzer Battalion encountered a Pershing from Company F, 2nd Armoured Battalion, 3rd Armoured Division, in close-range street fighting. The two tanks engaged at approximately 300 meters range, firing simultaneously. The Panther's 75mm round struck the Pershing's frontal hull armor and deflected without penetrating. The Pershing's 90mm round penetrated the Panther's frontal armor, detonating ammunition and destroying the German tank instantly. The engagement, filmed by American combat cameramen, provided visual proof that the Pershing could defeat Germany's most common heavy tank in direct combat. German tank crews who viewed the footage understood immediately what this meant. Their primary weapon, the Panther, could not reliably defeat this new American tank frontally. Every engagement would require tactical maneuvers to achieve flank shots while avoiding the Pershing's powerful gun. In Germany's collapsing defensive situation, with Allied forces advancing rapidly and German units fighting desperately to maintain cohesion, such tactical sophistication was increasingly impossible. The psychological impact on German tank crews was devastating. These men had grown accustomed to technical superiority over Allied tanks, confident that their Panthers and Tigers could dominate any engagement if properly positioned. The Pershing shattered that confidence. For the first time, American tankers possessed a vehicle that could match German heavy tanks gun for gun and armor for armor, while maintaining the automotive reliability that had always characterized American equipment. Reports from Panzer divisions facing American forces noted declining morale among tank crews as word spread about the new American heavy tank. Crews who had fought confidently against Shermans, knowing their Panthers could destroy multiple enemy tanks in favorable engagements, now faced an opponent that nullified their technical advantages. The Pershing could engage from safe ranges where German guns were ineffective, absorb punishment that would destroy German tanks, and reliably complete missions without mechanical failures. German intelligence assessed American Pershing production capacity based on manufacturing indicators and previous production patterns. American industry had produced nearly 50,000 Sherman tanks during the war, using multiple factories in different regions. The Pershing's more complex construction and heavier components would reduce production rates compared to Sherman's, but American industrial capacity suggested thousands of Pershings could be built annually if production was prioritized. Intelligence estimates proved remarkably accurate. American factories had begun Pershing production in November 1944 at the Detroit Tank Arsenal. Initial production focused on resolving mechanical issues and training crews, with combat deployment delayed until vehicles could be thoroughly tested. By March 1945, production had reached approximately 40 vehicles per month and was accelerating as manufacturing processes matured. Plans existed to produce 10,000 Pershings, replacing Shermans as America's standard tank. The war's end in May 1945 halted this production expansion, but the industrial capacity existed. America could have flooded Europe with Pershings exactly as it had with Shermans, overwhelming German forces through sheer numerical superiority backed by superior individual vehicle capabilities. The technical intelligence gathered at Sennelager influenced German thinking about post-war armoured vehicle development in ways that would not become apparent for years. Engineers who examined the Pershing and survived the war carried lessons learned into West Germany's Bundeswehr, where they influenced Leopard tank development in the 1950s and 60s. The Leopard 1 main battle tank, developed during the Cold War, incorporated many principles demonstrated by the Pershing. Emphasis on reliability and maintainability over pure performance specifications. Automatic or semi-automatic transmission, reducing driver workload. Powerful gun capable of defeating expected enemy armor at long range. Reasonable weight allowing strategic mobility without requiring specialized transport. These design philosophies traced directly to lessons learned examining American tanks during World War II. May 1945 brought Germany's surrender and the end of organized Wehrmacht resistance. The captured Pershing at Sennelager was examined by Allied intelligence teams recovering German technical documents. British and American officers reviewed German test reports, finding them remarkably accurate and professionally compiled despite Germany's desperate military situation. Post-war analysis by American and British technical intelligence confirmed what German testing had revealed. The Pershing represented a successful integration of German design principles with American manufacturing excellence. American engineers had studied enemy tank development, identified key advantages, and incorporated those features while maintaining superior automotive reliability that characterized American vehicles. The armor protection scheme, combining thickness with slope, proved highly effective against German anti-tank weapons. The automotive components demonstrated American understanding that reliability determined operational effectiveness more than maximum performance. The 90mm gun provided firepower adequate for defeating any German tank while using ammunition that could be manufactured at scale in American factories. German use of captured American tanks during the war's final months provided additional data about Pershing capabilities from the user perspective. Wehrmacht units desperate for reliable vehicles, as their own armor strength degraded, eagerly employed any captured American equipment they could obtain intact. However, no records exist of German forces capturing and operating Pershings, as the limited deployment and careful handling by American forces prevented any from falling into enemy hands operational. This contrasted sharply with German experiences using captured Shermans, which entered Wehrmacht service without modification because they worked reliably as designed. The lack of captured Pershings in German service reflected both the tank's recent introduction and American forces' careful employment of limited numbers in situations where loss was unlikely. The Pershing's combat debut in Europe, though limited by small numbers and late introduction, demonstrated conclusively that American industry could produce heavy tanks matching German capabilities while maintaining manufacturing and reliability standards German industry never achieved. The tank's performance validated American design philosophy, emphasizing practical functionality over theoretical optimization. American tankers who crewed Pershings praised the vehicle's capabilities in letters, reports, and post-war interviews. Crews appreciated the protection that allowed engaging German tanks confidently rather than relying on numerical superiority and flanking maneuvers. They valued the powerful gun that could defeat enemy armor reliably. Most significantly, they praised the automotive reliability that meant their tank would reach the battlefield and complete missions without mechanical failures. Fireball, the nickname given to the first Pershing deployed to combat, destroyed 3 German tanks and multiple vehicles during operations around Elsdorf and Cologne in March 1945, without suffering mechanical failure or requiring significant maintenance. This combat record in the hands of Sergeant Nicholas Maschlonas and his crew demonstrated that the Pershing could sustain intensive combat operations while maintaining reliability. The comparison with German tank operational availability told the story of industrial capacity determining victory. By April 1945, German panzer divisions reported catastrophic readiness rates as spare parts became unobtainable and fuel supplies dwindled. Panther battalions showed operational readiness below 30% in many cases, with tanks abandoned due to mechanical failures that could not be repaired. Tiger battalions fared worse, with complex vehicles breaking down faster than mechanics could repair them using improvised parts and inadequate tools. American armored divisions maintained operational readiness exceeding 70% throughout the final campaigns in Germany. Shermans continued functioning reliably, supplied by efficient logistics networks bringing fuel, ammunition, and spare parts directly to combat units. The few Pershings in service achieved even higher readiness rates, their robust construction and careful maintenance ensuring availability when needed. This disparity in operational readiness determined which side could sustain offensive operations and which had to carefully ration limited combat power. American forces advanced continuously, maintaining pressure that German units could not counter effectively. German forces fought defensive battles determined by which tanks were actually operational on any given day, unable to concentrate armor for decisive counterattacks because too many vehicles were broken down awaiting repairs that would never come. The Pershing's late arrival meant it influenced World War II's outcome minimally compared to the Sherman's overwhelming numerical presence. However, its capabilities influenced post-war American tank development profoundly. The lessons learned developing the Pershing carried forward into the M26, M47, M48, and M60 tank families that served American forces through the Cold War. These later tanks retained the Pershing's emphasis on balancing firepower, protection, and mobility while maintaining automotive reliability. They employed progressively more powerful guns as anti-tank weapons evolved, but the fundamental design philosophy remained consistent. Build tanks that work reliably under combat conditions, prioritize crew training and maintenance over pursuing theoretical performance maximums, accept that practical functionality matters more than impressive specifications. German engineers who examined the Pershing recognized these principles immediately. They understood that American designers had solved problems Wehrmacht engineers struggled with throughout the war. How to integrate heavy armor and powerful guns in a vehicle that remained reliable and maintainable. How to design transmissions that ordinary soldiers could operate without specialized training. How to build tanks that functioned in combat rather than merely looking impressive in technical specifications. The captured Pershing tested at Sennelager represented more than a single enemy vehicle brought home for examination. It was tangible proof that American industry had achieved what German industry never managed: the ability to design and manufacture heavy tanks, combining protection and firepower comparable to German vehicles with automotive reliability that German tanks never achieved. Weber's final report, submitted as Germany collapsed in late April 1945, concluded with observations about the broader industrial war. Germany had entered World War II with technical advantages in many weapons systems, possessing scientific knowledge and engineering expertise exceeding most opponents. However, Germany lacked industrial depth to maintain those advantages through sustained mass production, while simultaneously fighting enemies on multiple fronts. The United States had entered the war with weapons less sophisticated technically, but possessed industrial capacity to manufacture them in overwhelming quantities while continuously improving quality based on combat feedback. This industrial approach, exemplified by both Sherman and Pershing development, proved far more effective than German technical sophistication applied without sufficient industrial backing. The mathematics were clear when examined objectively. A Pershing that reliably reached the battlefield and fought effectively was infinitely more valuable than a Tiger II that broke down before engaging the enemy. A tank battalion with 80% operational vehicles could execute missions that a battalion with 30% readiness simply could not attempt. Reliability determined operational effectiveness, which determined victory in mechanized warfare. The Pershing proved America could match German heavy tank capabilities while maintaining superior automotive engineering. German tanks had consistently failed the reliability test throughout the war, despite impressive technical specifications. American tanks consistently passed reliability tests, while steadily improving firepower and protection until they matched German standards in those categories as well. Sennelager testing had proven this beyond reasonable doubt by April 1945. German engineers wrote detailed reports documenting their findings. They tested captured equipment with scientific rigor. They reached correct conclusions about American capabilities and German shortcomings. Understanding a problem and solving it proved fundamentally different challenges when industrial capacity was inadequate. The captured Pershing told the entire story through its combination of firepower, protection, and reliability. Every test that demonstrated the Panther could not defeat it frontally was evidence that German tank development had fallen behind American capabilities. Every examination revealing superior automotive engineering proved that American industrial maturity had surpassed German technical sophistication in practical application. The tank represented more than a weapons system. It represented America's ability to learn from enemy innovations, incorporate those lessons into superior designs, and manufacture those designs at scales Germany could never match. That capability decided World War II as certainly as any battle, proving that industrial capacity determined victory in modern mechanized warfare. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.